right, everyone. Get ready for a deep dive into a real cosmic puzzle, something that's been stumping astronomers for ages.
That's right.
You know, we always hear about these crazy things out in space like supernovas
Yeah.
or black holes.
Right.
But what about a star that just decides, hey, I'm going to crank up the brightness like 100 times brighter just because?
You're talking about FU Orionis back in 1936.
That's it.
This young star, it just suddenly became 100 times brighter, shining like 100 suns all at once.
Wow.
And the crazy part is it's been slowly fading ever since.
Really? So almost a century of just like chilling out, slowly dimming.
Pretty much.
That's wild. I mean, what could even cause something like that? Did it just like forget to turn off the lights or something?
Haha, not quite.
Okay.
It's not just some random star having a weird day. It's actually part of a special group of young stars.
Oh, so there's more than one.
Yeah, they're called FU Orionis objects, named after this first one we saw doing this. They're known for these sudden, super intense outbursts of energy, and those outbursts can last for decades.
Decades. So by understanding what's going on with FU Orionis, what can we learn from this whole thing?
Well, it can teach us a lot about how stars form.
Okay.
And even how planets might be born in these like chaotic stellar nurseries.
So we've got a whole group of stars that do this brightening thing.
Yeah.
What makes them different from, like our sun? Our sun seems pretty happy just shining away consistently.
That's a good question. And the key difference is something called an accretion disk.
Okay.
So most young stars, they have these swirling disks of gas and dust around them.
Yeah.
And that material is basically feeding the star, helping it grow, like a cosmic buffet.
Right.
It's like a cosmic buffet for hungry young stars.
Yeah, our sun must have gone through that phase too, way back when.
Billions of years ago.
But for these FU Orionis objects, their disks are they different somehow?
They're a bit more dramatic, you could say.
Dramatic.
They're prone to instabilities. Imagine like a perfectly ordered line of cars suddenly turning into a chaotic high-speed chase.
Oh, wow.
The rate at which material falls onto the star, it just spikes dramatically.
Okay.
And the star's magnetic field, which normally keeps things under control, it just can't hold back that much stuff anymore.
So instead of a nice, steady meal, it's like a cosmic force-feeding frenzy.
It's a great way to put it.
And that's where Hubble comes in, right? To observe this whole cosmic feeding frenzy.
Exactly. Astronomers used Hubble to look at FU Orionis,
Okay.
specifically in ultraviolet light, because they wanted to see what was happening in that zone where the disk meets the star.
Right.
They expected it to be hot, of course, but what they found was way hotter than anyone thought, like around 16,000 Kelvin.
16,000. That's got to be 3 times hotter than our sun's surface.
It is.
So it's not just that the star is eating more, there's something else making things super hot.
You got it, and that's where the real mystery starts.
Ooh, I love a good mystery.
Because the models we had for FU Orionis objects, they predicted a much cooler inner disk. So this unexpected heat, this is telling us there's something we're missing in our understanding of these stars.
Okay, so what are some of the theories? What could explain that extreme heat?
Well, one of the leading ideas is a shock wave.
A shock wave, like a cosmic sonic boom.
Exactly. So as all that material from the disk slams into the star at these incredible speeds, it creates this shock wave that heats up the gas to these extreme temperatures.
So Hubble's seen the glowing signature of this shock wave in ultraviolet.
That's right. It's not just the star itself shining brighter. It's this superheated zone where the disk is crashing into it.
Wow. So this shockwave theory is really making us rethink those FU Orionis models.
It is. It's challenging us to consider the complex dynamics going on in these systems.
It's amazing how one observation can turn our understanding upside down and lead to so much new research.
It really is.
But now I'm thinking, if a star is this volatile, what happens to any planets trying to form around it?
That's the million-dollar question.
Right.
We know planets form from these disks of gas and dust.
Yeah.
But if the star's going through these crazy outbursts, can planets even survive?
And if they do, I mean, what would they even be like?
That's what we'll be diving into next.
Can't wait. Okay, so we've got these FU Orionis stars just going wild, these young stars throwing these cosmic tantrums.
Right.
And we're trying to figure out, can planets even form? Can they survive in that kind of environment? It's like a cosmic demolition derby out there.
It's definitely a chaotic scene, but you got to remember, not all planets form at the same distance from their star.
Right.
Think of it like A planet forming way out in the disk, like in the suburbs of the star system.
Okay.
It might be far enough away to avoid the worst of those outbursts.
The distance helps.
It does.
But what about the planets forming closer in? I mean, those are the ones right in the line of fire when the star goes crazy.
Yeah, they definitely have it tougher.
Are they just doomed?
Well, it's not necessarily a death sentence, but it definitely makes things a lot more complicated.
Complicated how?
Well, for those planets forming close in, those outbursts, they could have a huge impact on how they evolve.
Okay.
So they could be bombarded with intense radiation, heated to these crazy temperatures, maybe even have their atmosphere stripped away.
Whoa, it's like a trial by fire, literally.
It really is.
So, do we know of any planets that have actually formed in these kinds of crazy systems?
We do, and that's what makes this research so exciting.
Oh, really?
Astronomers have found a handful of exoplanets, planets orbiting other stars, that seem to have formed in environments that look a lot like what we see around FU Orionis.
Wow, so these planets, they survived their stars like teenage angst phase.
They did.
What are they like?
Well, one of the most interesting examples is a planet called K233b.
K233b.
Okay. It's a super Neptune, meaning it's much bigger than our own Neptune. Right. And it orbits incredibly close to its star, which is a young, active star.
So right in the danger zone.
You got it. And what's fascinating is this planet, it's incredibly dense, much denser than we would expect for a planet of its size and age. And that suggests that it might have formed farther out in the disk and then migrated inward, surviving multiple outbursts from its star along the way.
Like a cosmic survivor? That's incredible.
Really is.
It makes you wonder if these planets that form around FU Orionis stars, if they might be, I don't know, tougher somehow.
Yeah.
More resistant to, extreme conditions.
It's a really interesting idea. It's possible they develop these unique characteristics, maybe even unique compositions because of the challenges they faced early on.
It's like a cosmic forge, shaping these planets into something truly extraordinary.
I like that, a cosmic forge.
So even though these outbursts are pretty dramatic,
yeah,
they might actually be helping to create these unique planets.
They might be. It's a reminder that even in all this chaos, there's still potential for creation.
Absolutely. And by studying these systems, we're not just learning about planet formation, we're also learning about how resilient nature can be and how it can create this incredible diversity even in the most challenging environments.
But there's still a lot we don't know about FU Orionis, right?
Right.
Hubble's observations, they're just the tip of the iceberg.
They are. Astronomers are still analyzing all that data, especially those spectral lines we talked about.
Right, the barcodes that tell us what the star and the disk are made of.
Exactly. By looking at how those spectral lines change over time, astronomers can track how the gas is moving in the disk.
Okay.
And they might even be able to see signs of planets forming right in the middle of all that chaos.
So even though this is kind of a crazy time in a star's life, it might also be like the prime time for planet formation.
It could be.
It's like those outbursts they're stirring things up, getting the planet building process going.
Yeah.
That's a good way to think about it. It's like shaking a snow globe. You create these clumps and swirls that could eventually come together to form bigger objects.
Wow, so maybe these FU Orionis stars, they're not just cosmic demolition derbies. Maybe they're also like cosmic construction zones.
Exactly, helping to build the next generation of planetary systems.
That's amazing.
It's this fascinating duality. And as we keep studying these systems, we'll get a much better understanding of the dance between how stars and planets form.
So it's not just about FU Orionis itself. It's about what it can teach us about the whole universe, right?
It is.
All those other planetary systems out there that might be going through similar things.
Exactly. FU Orionis is like a window into these chaotic but ultimately creative forces that shape the cosmos.
And that's what we'll be exploring as we wrap up our deep dive.
Sounds good.
Okay, so we've been on this wild ride learning about FU Orionis, this young star that's really shaking up what we thought we knew about how stars behave and how tough planets have to be to form in the first place. What stands out to you most now that we've come this far?
I think the biggest takeaway for me is just how much more there is to discover.
Yeah.
We've been studying stars for centuries, but FU Orionis is like a giant flashing sign that says, hey, there's still so much out there we don't get.
It really makes you feel small, doesn't it?
It does.
We think we've got it all figured out, and then boom, a star decides to crank up the brightness 100 times and throws all their series out the window.
Exactly. And the cool thing is, those surprises, they force us to rethink things.
Right.
Come up with new models, ask new questions. That's how science moves forward.
It's like they say, the more you learn, the more you realize you don't know. But, okay, we talked a lot about the science, but I want to bring it back down to Earth for a second. You know, for us humans, what does all this mean for us here on our own little planet? Does FU Orionis tell us anything about our own solar system?
That's a great question. And while FU Orionis is way out there, light years away, and our sun is, thankfully, a much more well-behaved star, studying these extreme systems actually helps us understand the bigger picture of how planets evolve.
Okay, so it's about seeing the whole context.
Is.
Understanding those forces that are shaping planetary systems all across the universe.
Exactly. By studying FU Orionis, we're learning about the crazy challenges that planets might have to go through in the beginning.
Yeah.
You know, the intense conditions they might have to endure. It helps us really appreciate the fact that our solar system is relatively peaceful, you know, that we're here at all.
It really makes you wonder, what if our sun had been like FU Orionis?
Yeah.
Would Earth have even had a chance?
It's a great question. And while we can't know for sure, it's pretty likely that Earth as we know it wouldn't exist if our sun had gone through those wild outbursts.
Oh.
The intense radiation, the heat, the instability, it would have been a very different story for our planet.
So are we just super lucky that our sun is so chill?
You could say that it shows how important it is to study all kinds of stars, not just the ones that look like our sun. By understanding the whole range of what stars can do, we can better appreciate all the different kinds of planetary systems out there.
Yeah.
And we can really understand how special our own situation is, that our planet is able to thrive.
So we're not just studying FU Orionis, we're studying the potential of the universe itself.
Right.
To create planets, to create life, to create something as amazing as our own planet.
Exactly. And that's what makes this research so exciting. It's not just about data. It's about expanding our understanding of where we fit in the grand scheme of things.
Yeah.
And realizing all the possibilities that are out there.
So as we wrap up our deep dive into FU Orionis, what's the one thing you want our listeners to take away?
I'd say the biggest thing is this. Never stop exploring. Never stop asking questions.
Okay.
The universe is full of surprises, things we don't understand yet. And it's through that exploration, that curiosity, that we make those breakthroughs, you know, and push the boundaries of what we know.
I love that it's been incredible exploring the mysteries of this crazy star.
It has.
And who knows what other secrets FU Orionis is holding? What other discoveries are waiting for us out there?
I can't wait to find out. I hope everyone listening will keep looking up, keep wondering, keep exploring. There's so much more out there.
The universe is full of wonders just waiting to be discovered. Thanks for joining us on this deep dive, everyone.